Hey class, welcome back to the lesson about the area of circles and sectors. So in the last lesson, we talked about the area of a circle, what a sector is, and how to find the area of a sector. And that's, the sector is a piece of the area, much like the arc was a piece of the circumference. And we made it in relation to the circle as a whole. Well, now we're going to see what goes on with something else called a segment. Okay, so we're going to talk about the area of a segment. Now, what is a segment of a circle? The segment of a circle is going to be formed by what is called a chord. Okay, so a chord is a part of the circle that goes to two consecutive points on a circle that don't include the center. Okay, so a chord is just 2 points of a circle being connected together that does not include the center, and that is a chord. So when we're talking about area, we can have the area of a sector, and we can have a chord that exists, and then we can find the area of a segment. Okay, so this is our segment. And we can find that area using an addition postulate, but with subtraction. Because the area of a sector as a whole is made up of the area of this triangle, and we'll talk about that briefly, and the area of this segment. So if we put this segment with this triangle, we get this sector. And so what we can do is use that addition postulate backwards with subtraction, and we can find the area of segments. Okay? But the challenge is we have this triangle. So what is the deal with this triangle that we have here? And if we're finding area of a triangle, we have to remember how that works. The area of a triangle is 1/2 the base of it times the height. So in this particular triangle that we're looking at here, we have our base, right? We know the chord is our base, but what is the height? The height of that triangle goes right from the center of the circle down to the chord. Okay, so we have some old material coming back real quick, so let me massage us into there. So what we can do is visualize that triangle getting popped out, and then we can take a look into our triangle. So if we can visualize what's happening, if we can pop out this particular triangle, that piece of the segment, or that piece of the sector, and then we can visualize this, we know that our chord goes all the way across the bottom, and we know that our radius goes from the vertex of the triangle because this is the center of the circle. So the radius of the circle is the same. So what do we know about this particular triangle that we're looking at as a whole? It is an isosceles triangle, no doubt. Okay, but it is an isosceles triangle, and that's helpful. The height of the triangle goes from the center of the circle down to the chord. Okay, and we can make a right triangle. So with a right triangle, we have got some memories, right? So we can make our right triangle knowing that between the radius and the height is going to be 1/2 of the central angle that was made up of the sector. If you didn't follow any of that, pause here or at least rewind it because that is important vocabulary all at once. So what we have to do is take a trip down memory lane for triangles. We have to remember we're dealing with right triangles. We may have special right triangles, 30, 60, 90. We may have trigonometry that we have to do with sine, cosine, and tangent. Oh, no! I know, you can handle it. It's all good. Or we may have the Pythagorean theorem at play. You never know what can go on when we're dealing with right triangles, so we have to be prepared for everything. Okay, so when we look at our original note with the area of a segment, we may think, big deal, so we have the area of a triangle. Well, hang on. This can get kind of challenging, so we have to be sure that we're visualizing everything and we know what's going on. This is the most important piece of the notes. So if you didn't understand anything I said, rewind and do it again and listen carefully, okay? So let's get to work, shall we? Yes. So here is our question. What is the area of the shaded segment shown at the right? And we're going to round our answer to the nearest 10th, which means we're probably going to have some crazy numbers appearing because we might be dealing with square roots and whatnot. Okay, so we know what we need. We need the area of our sector and the area of the triangle made up of the chord and the radius, radii. Okay, so this is what's happening. we can find the area of the entire sector just like we did in the previous video. So let's work with that. Now, how do we find the area of the sector? We think proportionality. It is a 60-degree central angle, and that's in relation to a whole circle. And the area of the sector is what we're looking for, but that's in relation to the area of the entire circle. Okay, so in this case, it's going to be pi times the radius squared. So that's how we will find the area of the sector, just what we did in the last video. So how are we going to find the area of our sector? We're going to cross multiply and divide. So we have 60 times, and then 18 squared times pi is a big number, 324, and then that will be divided by 360. Okay, then the rest we can do the tricky crossing out like I did before. So check this out. I'll show you some tricks. 0 cancels with 0. 6 goes into 36 6 times. And does 6 go into 324? It absolutely does. 6 goes into 324 54 times. So the area of the sector is going to be 54 pi square inches. Okay, that's the area of our sector. Now what we have to do is deal with the area of the triangle. Okay, so you got to remember we're dealing with the triangle. And so if we pop out the triangle, we're going to be looking for the base and the height because we know that the area of a triangle is 1/2 base times height. Okay, so what do we know? In our pop-out right triangle, we know that if this is our center of the circle and this is one of the points on the circle, we know our radius is going to be 18 inches. We also know that if the central angle is 60 degrees, then half of the central angle is 30 degrees, and then we have everything we need because we are dealing with a 30, 60, 90 right triangle. So remember how the 30, 60, 90 right triangle works. In a 30, 60, 90 right triangle, the hypotenuse is 2 times the short leg, and the long leg is the short leg times the square root of 3. So we have to remember that refresher. So in this case, if the hypotenuse is 18, that means our piece of the chord here is 9, and the height of our triangle is 9 times the square root of 3. So we now have our 1/2, our base, and our height. So how does that work? Well, we have the area is equal to 1/2 times the base. Now, what is the base? It's going to be 9 and 9. The base all the way across this triangle is 9 and 9, which is 18, which might make you pause for a minute and say, wait a minute, isn't that the same as the radius? Funny enough, it turns out that it is. Okay, so the how do we know? Because we have a 60-degree angle here, we should know we're dealing with an equilateral triangle. Okay, because 18 here, we know it's isosceles with a 60 degree. That means it's definitely an equilateral triangle. So yes, you could have noticed that we were dealing with an equilateral triangle, but just in case we weren't. So anyway, we have our 1/2, our base is 18, and our height is 9 times the square root of 3. So we can do the same type of division here. Half of 18 is 9. So the area of our triangle is going to be 9 times the square root of 3, or 81 times the square root of 3. So that's the area of our triangle. Okay, so we have the area of our sector and the area of our triangle. So remember the note. If we have the area of the sector and we have the area of the triangle, we can find the area of the segment by subtracting. So we can totally do that. Let's do that. So we would simply subtract. Okay, all we have to do now is subtract. So we have 54 pi minus 81 square roots of 3. And so the rest is calculator work, shall we? Shall we? So we push that into our calculator. How will we do that? 54 times pi is equal to, and we're going to subtract 81 times 3 square roots equals, and we end up with about 29.3 cubic units. And so that would be the area of that segment. So 29.3 square units. Sorry, I don't know why I said cubic. In this case, it'll be square inches. Okay, so this is round to the nearest tenth, and we have done that. So the rest is calculator work. All right, so that's how we find the area of the segment. Now, let's take a quick quiz and see how fast we can apply some of these notes, okay? So the first question in the quick quiz, what is the area of the sector of x, y, z? Okay, we're going to leave our answer in terms of pi. Well, our central angle is 120 degrees, so 120 is out of 360, much like the area we are looking for is out of the area of the whole circle, which is found using this. And the area of the whole circle is going to be pi times 6 squared. So our area is going to be equal to 120 times 36 pi divided by 360. Watch how fast we can get this done. 36, 360 is 10. 10 cancels the 0, it's 12 pi. And we have now found our answer to be 12 pi. So look how fast we can use those skills. Okay? Now we're going to use this in order to answer the next question. So the next question is, suppose that segment XZ is drawn. So we're going to suppose that segment XZ is drawn, which means we have a sector now. What is the area bounded by the arc XZ and segment XZ? So we're going to be looking for this area, which is the area of the segment. Now, how do we find that? Again, that was the current material. Okay, so what we just did. So we need to find the area of the whole sector and then the area of our triangle. Okay, so we're going to find the area of our whole triangle and then we can subtract. So how do we find the area of that sector first? And so we can find the area of this sector simply by looking to the left because we already found it. Remember, these circles are the same thing. 120 degrees, 6 meter radius. 120 degrees, 6 meter radius. The answer is 12 pi. So we know that the area of the sector is 12 pi. All we need now is the area of the triangle, so we have some work to do. So we have our pop-out triangle, and we know that we're looking for 1/2 base times height. Our radius here is 6 meters. That is our hypotenuse. The only thing we need now is this degree measure up here. If the central angle is 120, this degree measure is going to be 60. And so we now have a 30, 60, 90 triangle, but be careful because we now have a 30, 60, 90 triangle. You have to know which is your short leg, which is your long leg, and which is your hypotenuse. So in this case, we have to be careful. We have to be careful. Our short leg is our height. The short leg is half of the hypotenuse. The long leg is the short leg times the square root of 3. So that means the area of our triangle being 1/2 base times height. Woo. So the area of our triangle is 1/2. What is the base? So if half of the chord is 3 times the square root of 3, the other half of the chord is the same. So the whole chord is 6 times the square root of 3. And then the height, of course, is 3. And so we now know that the area of the triangle, we can do some quick division here. 6 divided by 2 is 3. 3 times 3 is 9. So the area of our triangle is 9 times the square root of 3. All we have to do is subtract these two values. So when we subtract those two values, I feel like I did something wrong because, no, I'm good. So we have 9 times, oops, excuse me, I'm going backwards. 12 pi is what we were looking with. So 12 times pi is equal to that. And we're going to subtract, what did we say? 9 times the square root of 3. And so we're going to subtract 9 times 3 square root equals, we'll get 22.1. And that would be our amount of meters squared. That is the area of our segment. And so that is how that works. So hopefully you enjoyed our little lesson on area of circles and sectors. And that's it for the unit on the area of circles. We'll finish the year with circles, but that'll be for the next unit. Hope you guys enjoyed. See you later.